Now, first topic for A2 physics is circular motion. To understand circular motion, you have to understand how force should act on an object so that it moves in a circular path. For that, let's consider this is an object. Now, this object is moving in this direction. So this is the direction of motion of the object. And I engage this object with a force. And that force is acting this way. Now, you all might understand that if force acts in the direction the object is already moving, object speeds up. What should happen? Object should accelerate. Now, what if uh, the same situation is there, but instead this force acting this way, let's see if this force acts in the opposite direction. What will happen? Now, this is how the force is acting now on the object, not in the same direction as the motion of the object or velocity of the object. It is acting opposite to that direction. What will happen now? Will the object accelerate, decelerate, or move with the same speed? Answer is the object will decelerate. Means slows down. Now, the third case. What if force is neither acting backward nor acting forward? What if force is acting perpendicular to the direction of velocity, like this? What if force is acting like this, perpendicular to the direction of velocity? This is force. Now, this force cannot speed up the object, neither it can slow down because it is not acting along, neither acting opposite to the direction of motion. So, what will this force do? This force will tend this object to move in a different direction because this force is not speeding up or slowing down, but still it is accelerating because it is a net force. So, this object, instead of speeding up or slowing down, it will change its course. And instead of going there, it will start moving in this direction. So, this is what will happen with this object. So this object will be moving this way, and the new direction of velocity will change like this. But there is a new thing that you need to understand here. Force is still perpendicular to the velocity. So it will be changing the direction of motion of the object again. So object will be bending again like this. So if I keep doing this thing exactly the same way, believe me, I will end up with a circular motion. Let me let me show it to you. See, if I reduce the size so I can fit this thing over here. If I change it so that it is along the velocity is along the direction of the new velocity. See, but I have to make sure that velocity is always perpendicular to the force. So force is continuously changing the direction of the motion of object, and see, it is not slowing down the object, neither it is speeding it up. It is just changing the direction of motion. And I am just completing the diagram. So if force keeps acting perpendicular to the direction of velocity, object turns in a circular path. See, and I hope by this it should be a complete circular path. See, object is moving in a circular. What is necessary for an object to have when it is moving in a circular path? Answer is it should have a force which is acting perpendicular to the direction of velocity. Okay, and this is the topic of the day. Force to make something move in a circular path. To move an object in a circular path, a force must act perpendicular to the velocity and towards the center of the circular path. This force is called centripetal force. A centripetal force. Centripetal force, a force that is pointed towards the center of the circular path. If an object is moving in a circular path with constant speed, just 1 second, I just lost the board. Start with constant speed, the net force on object is acting towards the center of the circular path. There can be different sources for different examples. There can be many reasons for an object to move in a circular path, but there has to be one particular condition that if an object is moving in a perfect circular path, there is a net force acting on that object, and that net force is pointed toward the center of the circular path. So let's see some examples. Examples, source of centripetal force. Listen, this is a topic that is very hard to find a question of in the past paper. There were some questions in old years exam papers, but recently it is very tough to find a question that is completely based on centripetal force or circular motion only. But this topic is responsible for about 15 to 20 marks sometimes, up at least 15 marks. But I have seen some papers where this topic can get you about 20 marks. Thing is that this topic can be engaged with 5 to 6 topics in your A2 syllabus. So this topic might appear indirectly in many topics, like it is very commonly appearing in gravitation. Then it appears in circular motion of like electric objects or electrostatic things like electrons moving in a orbit or something like that. So in some cases, very commonly it is seen in magnetic force questions, centripetal force, and the equations can appear over there as well. Then in sometimes it is also connected to oscillations. So it is connected to many topics, and that is why we studied it as the first topic in A2, because this topic touches many other topics. So it is very important topic, and you should be completely understanding this thing, that what is the centripetal force, how does it act, and what are the sources for these forces. Let's see the first one. Is a kid has attached a stone to a rope and moving it in a horizontal circular path. So a kid has attached a stone to a rope and is moving it in a circular path over his head. What is providing centripetal force in this case? So that is your question number one. Now, second, a moon is orbiting a planet, or a planet is orbiting the sun. The sun is orbiting center of a galaxy. So in these circular motion examples, in these examples where there is a planet or artificial satellite or natural satellite orbiting a planet, or planet orbiting a sun, or sun orbiting center of galaxy, what is providing centripetal force in these examples? These are examples of circular motion, okay? All of them are circular motion. What provides centripetal force in these cases? Then we go to the next one, which is a charged particle moves in a circular path inside a magnetic field. So what provides centripetal force in this case? Then an electron orbiting a nucleus of an atom. So who provides or what provides centripetal force in these cases? Okay, there can be one more coming to my mind right now. That is a car moving along a circular track. So what is providing centripetal force in these circular motion examples? Let's start with the first one. A kid has attached a stone to a rope. So what provides centripetal force? Answer is the tension in the rope provides centripetal force. So in this case, when you have attached a stone or something to a thread and moving it in a circular path, in this case, what provides centripetal force? Tension. What provides centripetal force in these cases? Answer is the gravitational force provides or actually acts as centripetal force. So what about a charged particle moving in a circular path around? Okay, no, sorry, it's not. It is charged particle moving in a circular path inside a magnetic field. Magnetic force on the field produced by moving charge acts as centripetal force. Magnetic force on the field produced by moving charge acts as centripetal force. Now, an electron orbiting, it is an electron orbiting a nucleus. Electrostatic attraction between the negatively charged electron and positively charged nucleus acts as centripetal force. And believe me, all the examples that we discuss over here, all of them will be coming up in your course all along your year. The whole year, in different topics, these things will keep coming back to you. So a car moving along a circular track, friction between road and tire as a component towards the center of circular path. Providing required centripetal force. So this is the introduction of centripetal force, how and what can provide centripetal forces. Now let's have some mathematical understanding of centripetal force. Centripetal force is directly proportional to mass of the object. And I hope you will agree with me that if there is a very heavy object and you want to make it move in a circular path, you obviously need a larger force. It is easy to turn a light object, and it is difficult, or it requires more force to turn a heavy or massive object. More mass, more centripetal force required. Less mass, less centripetal force required. So centripetal force is directly proportional to mass. Centripetal force is directly proportional to speed square. Centripetal force is directly proportional to 1 over radius of circular path. So if I mix them together, all of them, and merge them to one thing, it will be centripetal force equals to mass into speed square over radius of circular path. So if we write everything in a symbolic form, it becomes centripetal force, or sometimes we use centripetal force is mv square over r, where m is mass, v is speed, and r is radius of the circular path. Now, if whenever you write a formula in your notes, I will recommend that you make a separate, like you pay some attention on the required unit or the unit that you should use for those quantities. Now, what should be the unit for mass? What should be the unit for speed? What should be the unit for radius? And then what will be the unit for force? So answer is must be in newtons and m is mass in kg, speed meter per second, and radius will be in meters all the time. Okay. So tomorrow we will be tomorrow, not tomorrow. I mean, on Monday we will be resuming from the same point. Till then, take care.